Part 3. Algorithms and Neural Networks. AI uses algorithms. An algorithm is a set of instructions that a computer can execute. A complex algorithm is often built on top of other, simpler algorithms. A simple example of an algorithm is the following recipe. If you were going to make chocolate chip cookies, you would take the following ingredients and follow the recipe. You would melt the chocolate and the butter together. Then you would stir in the sugar, eggs, and vanilla. Then you would mix in the flour. You would then pour the mix into a greased pan and bake at 350 degrees Fahrenheit for 20 minutes, or until an inserted fork came out clean. Then you would remove it from the oven and let it cool before eating. But as a process flowchart, it would look like this. Now, if this was program code, you would write it as the following. You would declare your variables as chocolate, eggs, butter, sugar, flour, vanilla, and mix, and the code would be written as you see on the screen. So this is an example of an algorithm. Many AI algorithms are capable of learning from information or data. They can improve themselves by learning new strategies or heuristics that have worked well in the past. And key to the process of machine learning, and therefore AI, are neural networks. Neural networks are modeled loosely after the human brain, which is made of neurons. They are both designed to recognize patterns. Neural networks are made of interconnected layers of algorithms, also called neurons. The neurons are grouped into 3 different types of layers. The input layer receives input data. The input layer passes the inputs to the first hidden layer. The hidden layers perform mathematical computations on our inputs. The deep learning refers to having more than one hidden layer. The output layer returns the output data. Machines interpret and understand data through processing, grouping, and labeling these large amounts of information. The neurons feed data into each other and can be trained to carry out specific tasks. This happens by modifying the importance attributed to the input data as it passes between the layers. During the training of neural networks, the weights attached to different inputs will continue to be varied until the output from the neural network is very close to what is desired. These weights are meant to reflect the relative importance of the information that is input. As at this point, the network will have learned how to carry out a particular task. Did you know the human brain contains 86 billion neurons? With 16 billion neurons in the cerebrum? There are various types of neural networks, and they have different strengths and weaknesses. Recurrent neural networks are a type of neural network particularly well suited to language processing and speech recognition. Convolutional neural networks are more commonly used in image recognition. The design of neural networks are evolving, with researchers recently refining a more effective form of a deep neural network called long short-term memory, or LSTM. A deep neural network, or DNN, or deep learning, is where neural networks are expanding into sprawling networks with huge numbers of layers that are trained using massive amounts of data. It is these deep neural networks that have fueled the current leap forward in the ability of computers to carry out tasks. LTSM can not only process single data points, but entire sequences of data, which allows it to operate fast enough to be used in on-demand systems like Google Translate and speech recognition. The biggest breakthroughs for AI research in recent years have been in the field of deep learning.